sends over a neurotransmitter, for example, glutamate, to the presynaptic neuron. This neuron has dendrites and dendritic spines which catch these messages and begin to send that message to the next neuron. The dendrites, in this case, are the first to receive a message and begin to send it down to the axon. When going down the axon, there are three things to mention. One, when the message hits the soma and the nucleus, the message gets sent down further to the axon. The process of that message being sent from the soma to the axon is the start of the action potential. Action potential continues down through the axon where sodium ions rush in the axon and potassium rushes out of the axon. This process is called depolarization. As the message goes through the axon, it goes down the myelin sheath, these things, the outer covering of fatty tissues, as well as the nodes of Ranvier, the in-betweens, the non-fatty tissue coverings. The nodes of Ranvier are the uncovered bits of axon, whereas the myelin sheath covers that axon with a fatty tissue. The myelin sheath helps the neurotransmitters to keep moving through the axon down to the terminal buttons.
As it continues going down the axon, it reaches these axon branches, as well as terminal buttons, and these buttons then contain these synaptic vesicle, as well as the neurotransmitter. These vesicles then push out the neurotransmitters out to the synapse, right here. As it goes through the synapse, it must reach a receptor site, which could be right here on the different dendrite. If it doesn't reach a receptor site within a given time, one of three things will happen. It will either be dissolved, eaten by other enzymes, or have a reuptake action, where it will be reabsorbed back to the presynaptic neuron after it travels through the receptor sites. It travels into the postsynaptic neuron. Before it fires, though, the neuron hangs out and waits upon firing. This is called resting potential. It can be fired, it just doesn't want to at the moment. Once it's ready to be fired, however, it will fire at the same exact intensity as the last neuron did due to the all or none principle. After the neuron fires out a chemical message, it is then sending out to the other neurons, which this process will be repeated over and over again with the neighboring neurons.
That's how neurons work.
Yeah.